Alrighty, chapter 10, points in space. This chapter is just putting together a couple of ideas that we've already seen. There's nothing really fantastic here. What do we mean by points in space? I don't really like that terminology because to me, every point is in space all the time. It might be in two-dimensional space if we're on an XY plane. It might be in one-dimensional space if we just have a number line. Of course, we could have a point there. Heck, it could even be zero-dimensional space if it's just a point and no axes at all. But here they specifically mean points in three-dimensional space. Now, back in chapter 1, we definitely discussed the midpoint of a line segment in 2D, and I think we probably touched on distance formula in some problems there. So here's the distance and midpoint formula again, though. These are both on top. These are both in the data booklet on page 2 in the prior learning section. But now we're talking about 3 dimensions, so the formulas below are found in the data booklet on page 6 in SL 3.1. And you can see how naturally the formulas extend from 2 dimensions into 3 dimensions. And guess what? We can bring them down dimensions too. You could easily find the midpoint or the distance between two things in just on a line segment, and you can also extend these into 4 dimensions, 5-dimensional space, and so on. Our course only deals with 3. I know, kind of boring, but it is what it is. Anyways, that's all that section A is about. It's about, hey, use these formulas in 3D. And I'm not going to bore you with that. You just plug in the points. Super easy. Section B just has to do with like a little bit of measurement, so like the surface area volume stuff, except now instead of being given the lengths of the line segments, we're given coordinates. And we need to work out what the distances are using the formulas that we just saw on the previous page. So wow. All right, let's talk about this real quick. Letter A, verify that the apex would be point D, lies directly above the center of the base. So the center of the base be this point there. Well, what would be the coordinates of that point? Well, it would have to be kind of halfway along this line segment, halfway along this line segment, as well. So it looks like the x-coordinate then, and the x-axis here, by the way, is pointing out in this direction. So the x-coordinate is 4, so that means halfway is going to be 2. And then the y-coordinate, which we see is pointing out in this direction, is also 4. So the y-coordinate for the midpoint should be 2, and we notice that the midpoint, or the coordinates rather, for D, for its x and y, are both 2 and 2. Okay, and part B, the volume of the pyramid, we've seen that formula before, so it's 1/3 the area of the base times the height. The area of the base is obviously 16, the height is 5. I know the height is 5 because that is the z coordinate right there. So we easily calculate 80 over 3. And part C, we've got 3 parts to this. So M is the midpoint of BC. So using our formula, we calculate the midpoint's 240. Finding the length from M to D, now we use our distance formula in 3 dimensions. Using the coordinates for M and for D, we get square root of 29. And then we can use all this to figure out the surface area for this pyramid. We've got 4 triangles that we need to add together with the area of the base, which is a square. So the square we know is going to be 4 by 4. And then we have 4 triangles. And their areas half base times the height. Half the base is 2, and then we just figure out the height was root 29. So there you go. Some of you might have been a little uncomfortable in that last image, figuring out like how the x, y, and the z axes worked out. So I think this is a good time to introduce something called the right-hand rule, which if you're taking a physics course, for sure you'll hear about right-hand rules for, like, I don't know, electromagnetism or something like that. I don't really remember my physics too well, but it's really helpful for us to figure out where axes are in relation to each other. So if you stick out your right hand as in the image like this, you get the x, y, and z axes pointing in the correct directions for the positive directions as they would appear um, in a proper 3D coordinate system. Now the x and y axis, that's what we usually use. It's a little weird here, but maybe rotate your laptop screen or rotate your head, and you can see that the x and y axes are they're working together, right? So like we could have this could be the point 3, 1. Let me say 3, 1, 0 though, because it has 0 for its z coordinate now. And then, like I said, then the z coordinate's going to face kind of up here. Now, imagine taking your hand and rotating it so that now your index finger is sticking out of your screen right now. And so that way you'll have your y-axis is going to be pointing kind of towards the right, and then your z-axis is still pointing upwards, and you'll have the axes that we saw in this picture. All right, so that's a correct set of axes. We wouldn't want to have them all jumbled up pointing in the wrong directions. Anyway, let's move on to section C, which is the last one. So now this is just back to measurements with planes and a little bit of trig here. So we want to find the angle between line segment EC, so that's from this corner to this opposite corner, and the base plane, which is ABCO. So that's this plane here. So remember that we want, in order to find the angle between this line segment and the plane, we're really talking about the angle between that line segment and its projection on the plane, which is going to be connecting A to C. So we've got a right triangle now in 3D space. There's our right angle. And we can work out what that angle is using some trigonometry. And finally, if we just had 3 points, we can work things out from there as well. Because if we have 3 points, what kind of shape can we draw? A triangle. So just draw a triangle. It doesn't need to be to scale. Excuse me, perhaps I should use the correct IB command terms. Don't draw the triangle, sketch the triangle. And then figure out what the lengths of the various sides are. So fun. Look at those square roots. And then since we know 3 sides and we want to know an angle, we would use the cosine rule. There you go. And that's all there is for chapter 10. It seems that at least in this video, I am really taking to heart the anonymous advice, if you must be dull, at least have the good sense to be brief. And look, now you have a sick burn to use against me anytime I start rambling and telling stories in class. You're welcome.